Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on angular momentum. We will be learning about momentum and impulse. We will also discuss the laws of conservation. Let us get started. In physics, the angular momentum can be used to describe the overall state of an object or even a system. We can determine its direction using the right-hand rule. The equivalent to linear momentum in rotational dynamics is angular momentum, represented by L. It is defined as the vector product of the displacement from the axis of rotation, called r, and linear momentum, called p. We can substitute the equation for linear momentum into this equation. So, angular momentum is expressed in this way. If velocity, called v, is not perpendicular to r, then angular momentum is equal to the product of the axis of rotation, linear momentum velocity, and the sine of the angle between the axis and the velocity. Now, let us look at how to express angular momentum for something rolling or spinning. Picture a rigid object is rotating around an axis, such as a ceiling fan's blades. The angular momentum of the blades is the product when we multiply the moment of inertia and the angular velocity. we can determine the direction of the angular momentum by using the right-hand rule, which you have learned in earlier lessons. Look at this figure skater. She is spinning fairly fast. But watch as she draws her arms in towards her body. Her angular momentum gets much higher, even though she did not do anything to make herself go faster. Why do you think this is, class? Please form groups and try to think of an answer.
Students, let's get ready. Time's up. Let's get back to our lesson.
Welcome back, students. Could you think of an answer? Let us find out together. The skater goes faster because of the law of conservation of angular momentum. Angular momentum is conserved when there is no net external torque. In other words, the smaller a rotating body can make itself, the less energy it takes to spin. That means it will go faster using the same amount of energy. We have already learned what a linear impulse is. It is when there is a change in the linear momentum of a body. The impulse is the change in momentum or the mass multiplied by the change in velocity. The impulse is also related to the force used to change the velocity and is the force multiplied by the time it was applied for. In the same way, the effect of an unbalanced torque on a body that can rotate is to cause its angular momentum to change. It changes at a rate which is proportional to the magnitude of the torque. These principles can be used while we are learning about angular momentum. If we change the angular momentum of an object by altering the torque, it is called an angular impulse. Angular impulses can happen to objects moving in straight or curved lines. This is the formula for expressing angular impulse. As you can see, it is the product of torque and the time in which the torque acts. Therefore, it is also equivalent to the product of the moment of inertia and the change in angular velocity. Please make a note of this, students, because it will be useful in future lessons. Now it is time for another activity, students. We can study the principles of momentum using eggs as tools. Please divide into groups. Your teacher will give you each 2 eggs. One will be raw, and one will be hard-boiled. Spin the egg on its side, then stop and quickly release it. Try this with both eggs. Please go ahead.
Students, let's get ready. Begin. Let's get back to our lesson.
Welcome back, students. I wonder if you noticed the difference between the two eggs. If you spin the hard-boiled egg fast enough, it lifts up on its end and spins in place. Why? The motion of spinning the egg causes it to slip a bit on the desktop. This means one end of the egg spins a little more quickly than the other end. This tilts the egg a little, causing one end to lift into the air. The speed then increases because the center of mass is moving closer to the axis of rotation. Remember what happened with the skater? This, too, is conservation of momentum in action. The raw egg has liquid in it. This means that the center mass does not move as quickly when you spin the egg. It dissipates the kinetic energy, and the egg can't go fast enough to lift up on its end. That is all for today's lesson, students. Today, we have learned about angular momentum and angular impulse. Remember that the formulas for expressing angular momentum are different if the motion is curved or a straight line. To remember the law of conservation of momentum, just think of the figure skater and the egg. We will have more fun next time. Until then, thank you, teacher. Thank you, students.